glaciers shape the landscape? Glaciers are frozen rivers of ice which have immense power. Glaciers are so powerful, they can carve huge chunks out of mountains as they flow downhill. This makes them one of the most powerful natural tools on our planet. Glaciers are sometimes called nature's bulldozer. Just like a bulldozer, glaciers shape the land in 3 ways. Firstly, glaciers pick up material. We call this erosion. Water flowing along the bottom of the glacier seeps down into the rock below. When it freezes, it opens up the cracks in the rock. This is known as freeze-thaw weathering. Then, as the glacier flows downhill, pieces of rock come loose and the glacier pulls them along with it. We call this plucking. Ouch! These rocks and stones scrape along the glacier bed like sandpaper, taking more rocks and stones along for the ride. This is called abrasion. Secondly, the glacier transports this eroded material as it flows downhill. Some of it is hidden inside or at the base of the glacier where it can't be seen, but sometimes it is transported on the top of the glacier. This is why glaciers often look dirty. As the glacier flows down a mountain, it gets warmer and starts to melt. Just like a snowman, anything which cannot melt is left behind. As the glacier melts, the rocks and stones fall to the ground. We call this deposition. By now, this material is a tasty mixture of rocks, stones, sand and clay, known as glacial till. The melted ice turns into meltwater and flows downhill to join a river or lake. Today, glaciers only exist in the coldest parts of our planet. But during the last ice age, glaciers existed in the UK too. Although the ice has melted, they have left behind some awesome scenery. As our planet warms up, many of our amazing glaciers are melting fast. So grab your walking boots and head to your nearest glacier while there's still time to see nature's bulldozer in action.
Alright, so hopefully you have a better understanding of how a drumlin forms after the 2 videos that we posted. And here's just another picture of a drumlin. Again, you can see the left-hand side is the steep side and the gentle side is on the right-hand side. Therefore, the glacier was moving to the right. We don't have a compass here, so we don't have a compass direction.
But we do have some digital wizardry skills. I could show you the arrow showing the direction of the advancing glacier. That's the direction the glacier was advancing. And from that one video, you know that there's another way to pronunciate glaciers, and that's glaciers. Glaciers. So this is a real world picture of a drumlin. These are also drumlin pictures. All the sediments in here would be unsorted. So if you dug through this, you would see glacial till, unsorted materials. That's a real drumlin, real life. Again, all unsorted material.
Just remember to associate anytime you have anything having to do with glaciers or glaciers, that is unsorted material. So here in this picture, you can see you have your drumlins. We have an esker. We have kames, kettle lakes, terminal moraine. When we talk about glaciers, a drumlin is a hill of sediments left behind by a glacier. Therefore, the drumlins would be unsorted sediments. An esker is another type of hill that's left behind by a glacier, unsorted sediments. Terminal moraine, marking the furthest advance of the glacier, is another type of hill left behind with sediments, so unsorted sediments. However, when we talk about the meltwater from glaciers, the meltwater, this is water-moving sediments. If you have water-moving sediments, that's now water, so therefore they are sorted.
You'll sometimes see the outwash plain. So the sediments depositing the outwash plain would be by running water, and that would be sorted. You'll sometimes see the word braided streams, and they look like hair braids. Braided streams are from the meltwater of the glacier. Those sediments would be deposited, would be sorted sediments.
And if you think about just the words outwash, the word wash meaning water, associating with water, that's going to be sorted. Okay, and streams, any sort of stream is going to be sorted.
When we get to kettle lakes, we'll do kettle lakes a little bit later on, but Lake Ronkonkoma is the largest kettle lake on Long Island, formed by a glacier. So this is a picture, and you can see what shape is that valley. So therefore, it must have been formed by a
glacier.
This is a glacial erratic. Therefore, the composition of the actual erratic itself does what in comparison to the bedrock below?
Does not match.
Because it was transported by a
glacier.
So think about the size of that glacier to transport this. And here's a picture of a terminal moraine. What do you notice about the sediments there?
Sediments are all unsorted, and I also noticed a gentleman playing on the unsorted sediments.
That would probably be fun. And here would be the actual
glacier.
And the glacier is retreating, and as it retreats, it dumps off this material. That's all unsorted material. And that is a very famous, iconic place. It's called Half Dome. And this is a picture, a very beautiful picture. This one's a little bit easier to see. And half of this was ripped off by a
glacier.
And then you can see the U-shaped valley here as well. So a glacier knocked off half of that mountain, that cliff face.
All right. So again, in your notes, you have already completed drawing your drumlin, and you have marked the way that the glacier was advancing, and you have your steep side and your gentle side. All right, so now we're going to start with wind erosion. You should be up to this part in your notes. Let's begin.
So not directly related to your notes, but just a generalization that wind carries sediments that grind against the rock. Think about like sandblasting, grinding it down, smooths the rock like
sandpaper. If you take a look at the right-hand side picture, you'll see the sand being blown around. Okay, it doesn't blow high up in the atmosphere necessarily. Most of the sand, most of the time, is blown closer to the ground, which is why you wind up with shapes in the desert like this, almost like a mushroom shape, where the bottom's being sandblasted and the top, there's more of it left.
An interesting thing, but rocks are very strong compressionally when they're being compressed. So that's why this very thin column can support this heavy weight. And think about the stone columns we saw in Washington, D.C. that were holding up these huge, enormous pieces of rock, because rocks are very, very strong when they're being compressed or being weighted on. And that's why it can maintain that level of weight above it.
Okay, so this actually is in your notes. Now we're going to fill it in. So wind erosion occurs primarily in dry climates, kind of like the desert that we just saw. And particles are sorted. Just like water, strong wind can carry larger sediments. Wind that doesn't travel as fast, weaker winds can only carry lighter particles. So you'll wind up with a sorting. And then sediments that are being hit by that sandblasting, we're going to have that frosted or pitted look. We'll have more pictures of this later.
Deflation is the removal of loose sand particles by the wind. So the wind is going to remove those lighter particles, and what will be left behind are the larger particles. And over time, it's going to create something called desert pavement, and that's what that picture is showing you, as well as this picture. This is a picture of desert pavement. It almost looks like somebody came in and constructed this. It actually happens from the wind, because the wind is able to remove the lighter particles. The heavier particles are left behind. Given enough time, it's going to form desert pavement. And you have pictures of that, a progression of that, where it says deflation, and you know it's then deflation, more deflation happens, and then eventually you wind up with desert pavement. Those heavier particles on top will actually protect the materials below from being eroded away.
So really, deflation is the process that can form desert pavement as it removes the smaller particles from between the larger ones.
So this is going on now with something else called a vent effect, but let's go over our notes first. Abrasion. It happens when sand grains carried by the wind weather and erode the surfaces they hit. Vent effects are just a specific type. Over time, they're flat surfaces on the surfaces that are facing the prevailing winds. It develops over time, obviously. So you have a picture of a vent effect there in your notes.
You can actually imagine right here, you can imagine the sand blasting as the wind blows against this rock. It's going to carry sand that's going to hit that rock. So over time, you're going to wind up with this flattened surface as it abrades away. This you can also find in your review book. Okay, so we have some evidence of wind erosion. You have this mushroom shape here. Okay, where the bottom of the column has been eroded away by sandblasting. And then we have vent effects, where it starts off like this, and as the wind sandblasts that rock, you can see the surface becomes flat, frosted, and pitted.
And the other thing, letter B is kind of interesting. So those are telephone poles, and they realized over time they had a pile of rocks around the bottom of it, just the base of it, because the wind erosion, the sand particles, you could see it. It says it's sawing it off. So it was acting like a saw, and that wood's not as strong compressionally as rock is, and those telephone poles were falling over. So they learned that one the hard way, but I find it kind of interesting. And the last one is just desert pavement, which we already talked about.
Okay.
Some pretty cool pictures of Death Valley. These rocks move over time. It was kind of a phenomenon. They had to study it and find out what happened. It's some really interesting process, because at night the temperature drops so much that the tiny bit of water that might be stuck under that rock freezes, and then the winds push it because it has like a frozen bottom. There's less friction. So kind of an interesting thing. There's just a couple of pictures of them.
That's so cool.
Yeah. Isn't that neat? So.
Okay, again, let's go back to the ventifact for a moment. You get diagrams like this that show you how a ventifact would form as a result of wind erosion. And then here is a real picture of wind erosion. So look at this flat surface right here. And you know what? It kind of looks like a V, but that's all right. So the wind abrades away the surface. This is your ventifact, and you can see this desert pavement below it. Here's that frosted and pitted look. Not only do we have a ventifact, but you can see this looks frosted and pitted. So we can tell that wind erosion with sandblasting caused this.
Yeah, we've already talked about this, just in case you want to see it again. Some really cool pictures of some wind erosion. And going back to this, when we give you the bigger version of this picture, we really like it. This is an example of a mushroom-shaped rock, but you can see that the wind is only going to carry that sand at a certain height, and that's why the lower parts of the rock were eroded more, because the wind will only carry it a certain height. Sorry, I clicked on the actual picture and it jumped to the source. More mushroom-shaped rocks. This picks up where your notes are again. Okay, so deposits by wind, the particles deposited are finer than water deposits. The deposits are well sorted, and they usually form tilted layers with cross-bedding. So this is rock that's showing you evidence of cross-bedding. That once was just sediment, and then it solidified into rock. So that's like a record of cross-bedding, which is really cool looking.
It almost looks, you can actually see the tilting and the cross-bedding.
Probably from shifting winds.
Right. Now we're up to sand dunes. Sand dunes are also formed. Sand dunes are formed by wind erosion and deposition. Okay, and we're going to show you how sand dunes can actually migrate or move over time. So
the different lines here, the solid line represents where it started off. Then you have a dash line. Is it moving? And then the dotted line is where it ends. And that would all be caused by prevailing winds maintaining their direction for quite some time. And through some digital wizardry, this is the arrow that you're going to draw to represent the general wind direction, or the prevailing winds. So just draw that arrow in your notes.
Okay, so if you look here, the wind is coming from this direction. And how can we tell that? Well, you have a gentle side, then a steep side. So the wind will pick the sediments, up, the sand sediments, and then they fall down the steep side. And then it will blow them up this side, and then they get dropped off on the steep side. So over time, it will continue to migrate in this direction with a general gentle side and then steep side. This is how this happens. If you start with, if you start with a pile of sand, the prevailing wind direction may be coming from here, and it will begin to blow the sand. Sand then will be moved up this gentle side, and then it falls off. And that means that the sand dune will begin to migrate in this direction, keeping that general form.
This just shows you that how the sand dune is shaped from the prevailing winds. So this This is pushing the sediment this way and piling the sediment high, and then when it gets to a certain point, that sediment falls down and creates that steeper slope. So based upon the shape of the sand dune, you should be able to tell us the prevailing winds, or if we give you a pile of sand with the prevailing winds, you should be able to draw the shape of the actual sand dune. And this just gives you the opposite direction, showing if the winds were coming from the opposite direction. That's the creation of that particular sand dune.
So that's how a sand dune can actually show you which direction the wind is coming from and what direction it will migrate.
So here's just a picture over time. You can see it started in 1953, and then these are the different dates, the different years that the sand dune is migrating and moving. And obviously this could be a real problem if you're in a town over here. So they call it desertification, where the desert is actually migrating, but it's happening from sand dune migration. So here's a picture of a real life sand dune. Pretty cool looking. Right?
And I can see the steep side. This looks like it's the steep side over here, right? To me, at least that's what it looks like. So then I would say the wind direction is probably coming from here. And then it's falling. I don't know.
So here is just that sand dune migrating, or the desertification. Those are telephone poles, or were telephone poles. And
Used to be a road.
Yeah, you could see the road in the background. Pretty incredible stuff, devastating, right, for areas. This is a picture of Valley of Fire, which is in Nevada. It's Nevada's oldest and biggest park. Really beautiful. We actually took that picture. It's quite nice. Really cool evidence of wind erosion there. So pretty cool looking. Desert Sandstorm.
Not the song either.
No.
This is sand being picked up and it's traveling across desert. Again, it's not extremely high up in the atmosphere. It usually travels kind of low unless you have a severe storm.
And camels have special adaptations to deal with this particular thing. But imagine you're a human being. If you breathed in that air, you're breathing in quartz, and that would cause a lot of damage to your respiratory system. And there you can see the sand particles in the air being carried by the air. And there's some evidence of wind erosion.
Again, frosted, pitted.
Mushroom-shaped rock.
All sand erosion. Just like that. That's kind of cool, and I'm not that tall, and I wouldn't be able to do that. Again, frosted, pitted. And that's what we have for that.
So now you're going to watch a thing about sand dune overtaking a home in Silver Lake. It's a pretty impressive video. It just kind of reinforces some of the stuff we talked about.
In Sterling, outside of our downtown Kalamazoo studios here in the heart of downtown, take a look at this video. A sand dune in Silver Lake is overtaking a home. All new at 6, Ellen Baca of Storm Team 8 went to that dune to find out why this is happening.
Properties in Silver Lake are slowly being swallowed up, but it's not the water that residents have to watch out for, it's the sand. Each summer, Silver Lake in Oceana County is packed.
There's boating and water skiing and swimming, the dunes, a lot of good food in the area.
The hundreds of acres of dunes that line the lake are the only in the Great Lakes that allow off-road vehicles. Not only are these dunes a big attraction, they also have a reputation.
And I've heard about anywhere from 6 to 10, 12 other cottages that have been covered up in the past.
The sand dunes are slowly swallowing anything in their path.
Well, there was a road at one time that went a good portion around the other side of the lake, and that has been covered up.
This year, the dune claimed another property. This was Phil Dressler's house. Now it stands in splinters with windows smashed and the roof collapsed. Jody says the past 2 winters have been especially warm, likely allowing the sand to consume faster than usual.
In years like these last 2 years, we may have had a movement of 10 to 12, 14 feet.
Years past, the homeowner, Dressler, received permits to move the sand away from his house. A year ago, he died and left the property to his son, who didn't move the sand in time to save the house. It's not clear what he plans to do with the property. Still, the permit process is a silver lining for others with houses on Silver Lake, because the sand isn't stopping anytime soon.
That it will just slowly cover up entire forests, and you can see as you get closer to the dunes where entire trees just slowly get covered up.
The next building that's in line for the sand dune is this 3-car lighthouse garage, which was also owned by Phil Dressler. In Silver Lake, Ellen Baca, 24 Hour News 8.
We know there's been a lot of terrible weather here on the East Coast, but out in California and the West Coast been hit by El Nino storms, which has caused a state of emergency. And we have some drone video. Check this out. These apartment buildings are teetering on the verge of disaster. And ABC's Neil Karlinski is out in Pacifica with the latest on this. Good morning, Neil.
Michael, good morning. We're up on top of that bluff. This is as close as we can get and stay safe, and here's why. Look at the edge. The pavement just crumbled away. Another 20 feet used to go out there, all of it falling over the edge over just the last 2 weeks. This morning, El Nino's fury caught on camera. Drone footage shows a chunk of this bluff in the city of Pacifica shearing off, leaving an apartment building dangling precariously. Residents told to leave immediately, their balconies right over the crumbling cliffs. Take a look at this. You can see where it's cracking away right outside. I don't even feel comfortable standing here, to be honest. The city in a state of emergency, up and down its coastline, pounding waves and powerful rains wreaking havoc, damaging a pier and opening this sinkhole. Engineers scrambling to fortify the sandstone bluffs with boulders, rods, and concrete from the beach below. Too late for this home, the ground under the patio crumbled away. Pictures from before this season's storms show just how much erosion there's been.
It's going really fast, really fast.
Even so, many of the people evacuating this apartment building this morning say they don't want to go.
Guys will have to physically drag me out. I'm not leaving. My neighbors aren't leaving either.
As much as they're doing to shore things up here, they know it's really up to Mother Nature now. George and Robin?
Boy, I don't know how you could not move away from that cliff. Wow. Okay.
All right, we're going to take a look at beach erosion. Now, beach erosion happens when sand is picked up by waves and moved from the area it came from to another location. Now, we discussed this before when we discussed Long Island, where Montauk Lighthouse has eroded away, but that beach sand seems to travel west. So this is called longshore drift. So the waves come in at an angle, just like these arrows show. Okay, and then they pull back out. And you know that from standing at the beach, if you stand in the waves, they do pull back out. And they pull the sand with them. So as the waves come in, they come in actually at an angle. And then they pull out the sand. And then they come back in and pull out. Just like this. So you'll have a longshore drift that will take the sand from one location and move it down the beach over time. Now, humans have been trying to deal with the longshore drift and to preserve the land that they have of their beaches because, well, beaches bring people love beaches, so we don't want to lose our beaches. So we go through these heroic actions to try and save the beach land that we have. Remember we talked about Montauk Lighthouse, how the waves would come in and then pull sand out and come in and pull sand out. And it slowly moves along. Now, this causes a problem where beaches are eroded away, which means the sand is taken away, and sometimes it's deposited in places we don't want it to be deposited in, like inlets. We want to keep inlets or these waterways open for boats to be able to reach the mainland of Long Island. So we're going to talk about the ways that humans have tried to stop or slow the process of beach erosion. Okay, here's the longshore drift, a longshore current. Okay, that we have going on here, where you can see these arrows show you the sand moving this way down the beach as the waves come in. Now, let's start with groins. Groins are one of the ways that humans have tried to deal with the longshore drift and preserve the beaches that they have. You might have seen these maybe in Long Beach. Okay, they're giant rock structures that humans build, usually out of boulders. So they'll make these big rock structures that will extend out into the ocean. They run perpendicular to the beach. Now, if you've ever been to Long Beach, you'll notice that one side of the groin will have sand that's deposited, and the other side looks like it's being worn away. Because the waves don't come in at a straight angle, they don't come straight in and go straight out, they actually come in at an angle. You'll see erosion on one side where the wave comes in and grabs the sand. And then as the wave goes back out, like we talked about, it will hit the boulders that are located on the groin and drop off the sand. So that's why on one side of the groin, you'll see erosion occurring, and on the other, you'll see the sand being deposited back off.
So the big boulders, what they do is they slow the velocity of the water down, the waves down, which then, since the waves slow down, the water slows down, then you get more deposition than you get erosion. So that's why they put those gigantic boulders. Remember, boulders require a higher velocity to move them, and they're big enough that water velocity is not strong enough to move them, and therefore it slows the water down, which causes deposition.
And here's an actual picture of what they look like extending out into the water. You can see these giant rock structures extending out into the water here. Okay, now the erosion depositional side isn't in this particular picture, you can't really see, but there are pictures we're going to look at where you can. Again, here you have groins extending out into the water, and the wave will come in, it will grab the sand from here, and then it will hit this other groin and drop it off.
Because the velocity of the water slows down. I just want to go back to one picture for 1 second. You neglected to talk about this. I was actually in a pogo stick, and Mrs. Bosham was on my shoulders, and that's how we got that picture. So surprised I didn't mention that. I guess you don't like to brag, but I was impressed.
You're really good on a pogo stick.
Well, you're really good at taking pictures on top of somebody's shoulder on a pogo stick. That's, I think, more impressive.
Okay, so here we can actually tell which direction the longshore drift is heading or going because of the erosional depositional pattern that you're looking at here. Since we have erosion here and deposition here, we know that the transport of sediment is headed in this direction because the wave would come in, grab the sediment, and hit the rock structure and then drop it off. Here's a really good picture, again, of a groin. Now we're looking from the ocean view, which we did not use a pogo stick. Okay, so I don't know what device we use this on.
Whatever they call that thing where you're in the water and you put those things on your ankles and it shoots the water out and you fly up in the air, and you're on my shoulders for that, whatever that thing's called. But we have some, yeah, we have water jet. Good, we'll call it a water jet. Okay. So here we have some digital wizardry too to help out, to make it a little bit more interesting, a little bit more, so what I'm looking for.
Well, let's look at the erosional
better understand.
Depositional pattern here. So we have erosion on this side, and you can see obvious deposition on this side. So now we have to figure out what direction the longshore drift was coming. Now you have to imagine that this picture extends beyond the slide that we're showing you. Okay?
Click that mouse.
All right, I'm going to click it. So here we have our erosion, we have our deposition, and the longshore drift would be going this way. Because if you imagine, the longshore drift would grab the sand here, and then the sand would travel and probably drop it off at another groin over on this side, but we don't have the extended picture of it.
So this makes beach maintenance a lot easier because essentially you're going to grab the sand from here and then bring it back over here. You'll get in your truck, grab it from way over here, and then bring it back to this area to try to minimize the erosion in the beach area.
Yeah. Okay, so this would be a question that might be asked. So here we have our groin structure, okay? And it shows us the direction of our longshore drift. That's really good. So the groin structure will change the pattern of deposition along the shoreline, initially causing the beach to become. Now, if you imagine the waves coming in, going out, and they're headed in this direction as they come in and go out, come in and go out, where would we get a buildup of sediment?
Notice that the compass direction is indicated on the bottom or toward the lower right-hand corner of the diagram.
So we would get wider on the eastern side of the groin. Now this is the eastern side because you have east. Here's the eastern side. Again, sand would be grabbed from over here, and then as the wave goes out, it will hit that groin and drop it off there. Here we'd wind up with erosion because the wave would come in, grab the sand, and move it down the beach this way.
This question is absolutely impossible without indicating to you the longshore drift. Mm-hmm. So either they'll tell you the longshore drift and ask you for the depositional pattern, or they will give you the depositional erosion pattern and ask you to determine the longshore drift.
Okay, so for instance here, we have deposition on this side and erosion on this side. What direction do you think the longshore drift is going? That way.
Okay, because when the water hits this area, it has sand in it, suspended in it. When it hits this wall, it slows down the velocity of the water, which then leads to deposition. This wave comes in and hits the sand, and there is no wall. It's not going to run into a wall until later on, way over here. So the process of erosion will be dominating in this area. So you're going to watch a really cool video again. And this talks more in more detail about groins and the real world implication of them.
Along Pawleys Island, 24 groins line the beach. Originally built in 1950, the walls of wood and rock are structures the mayor says are crucial to maintaining their town.
These groins have helped stabilize the beaches and protect Pawleys Island through Hurricane Hazel and Hurricane Hugo. They're still here and they're still doing their job of protecting the island.
In fact, Otis says the physical proof of their effectiveness is in plain sight. Stairs from these homes have been extended farther out to meet the shore since the groins were improved 13 years ago.
Where we're standing, the dune line has moved 75 feet toward the ocean and a whole new dune line has been created.
But with every solution, there's a drawback. For groins, it's called downdrift erosion.
The currents are going to move what they can move, and you can obstruct it locally and trap some, but it's going to excavate on the other side to make up the difference. So you kind of push the problem around.
Otis says their groins have not prevented sand from building up on the south end of the island.
So if downdrift erosion is in fact that significant an issue, then certainly at least one or more groins might have been required to be removed, but they haven't.
So you're back from the video, and we're going to discuss, not much more to go, by the way. Be pretty quick. So we're going to talk about breakwaters, which is just a different approach to minimizing beach erosion. And you could see that they just build these structures out here. They go parallel to the beach. And what that attempts to do, so we still have our longshore drift coming in, and it's going to take that, the beach will still get eroded, but when the waves come out to try and leave and take that sand with it, the velocity of the water slows down because it's a barrier. It's like hitting a wall. And then what process will happen? Well, then we'll get deposition. So this breakwater with this longshore drift will give you this depositional pattern over here. So that's what a breakwater is. So again, another picture of it, a diagram of it. So you have your incoming waves. And when those waves hit that breakwater while they're pulling that sand out away from that beach, it slows down, the velocity slows down, and then deposition predominates. And that's a real life picture of a breakwater. So the downside to it is some people say aesthetically they don't look so great. And then that depositional pattern interferes with people swimming and all that other fun stuff. It's just another approach to minimize beach erosion.
You see the waves had come in, eroded the beach away, tried to leave with the sand, and hit the breakwater and dropped the sand off. Here's, again, you don't have to know much about breakwaters. This is the extent of the questions that we have seen really about breakwaters, nothing too crazy. Okay, the size of the sandy beach at point D, what will happen to it? Well, you'll get erosion over here. And as it tries to leave, it will drop the sand off. So the size of D would increase. Okay, so now let's talk about a jetty. A jetty is just like a groin. It runs perpendicular to the beach, okay, but it's meant to keep waterways open. That's the only difference. So
it's basically like having two groins next to each other.
Right. Or sometimes, depending on the longshore drift, they'll even just put them on one side. So you'll see an erosional, depositional pattern with jetties depending on the longshore drift.
And in this diagram, the previous diagram, they're using the word accretion instead of deposition. Just a slight change in verbiage, that's all.
Right. Accretion, right. And they're also using the word littoral drift, which I had mentioned way earlier. If you remember, that littoral drift is longshore drift. And you can see as the waves come in, it tells you littoral drift or longshore drift is going this direction. So then it would come in, hit this jetty, and drop off. So you get your accretion or depositional side over here. And the waves would come in, grab the sand, and then continue to go if there's nothing there to stop it, which is why we have erosion on the other side. Here's an example of what you might see at a jetty, and you've definitely seen them on Long Island. Jetties, again, are just like groins, so you'll see it running out here, but it's trying to keep this waterway open so boats can go in and out. We're getting our deposition over here. I don't know if you can see, but over here, here's our erosion. So the beach gets eroded away, and as the waves try to go back out, it deposits the sand over here instead of in the inlet. They're trying to keep inlets open. Here's our longshore drift on Long Island. We talked about it going from the east end and heading down Long Island westward. Now, this is a problem, again, for not only just beaches, but to keep waterways open, that can become an issue. So we have quite a few inlets on Long Island, and they build jetties at these inlets on Long Island in order to try to stop the sand from building up and blocking the boats from entering and leaving. So again, our longshore drift heads west, and you'll see that we have our jetties that are built here to keep these inlets open.